Okay, so let's see if you know enough math to solve this math word problem, which is the following. A ladder's maximum angle is 75 degrees for safety. How long of a ladder is needed to reach 90 feet? Okay, so that is the question. Feel free to use a calculator, but go ahead and put your answer into the comment section. I'll share the correct solution in just 1 second. Then, of course, I'm going to solve this problem step by step. But before we get started, let me quickly introduce myself. My name is John, and I have been teaching middle and high school math for decades. And if you need help learning math, check out my math help program at tcmathacademy.com. You can find a link to that in the description below. And if this video helps you out, or if you just enjoy this content, make sure to like and subscribe, as that definitely helps me out. All right, now before I share the answer, let's take another look at the question. All right, now this first part could be a little bit confusing. So a ladder's maximum angle is 75 degrees for safety. So what does that mean? Well, here, let's suppose we have a ladder and it's leaning up against a building or something, right? So this is not much of an angle. But if we really put that angle of that ladder very steeply, now of course you got to know something about degrees, right? So here, this is 0 degrees and this is 90 degrees. So we can't make the ladder too steep. Matter of fact, the specifications for this ladder is the steepest that you can have the ladder is 75 degrees for safety reasons. So if we kind of max out that ladder, how long of a ladder do we need with this particular specification, right? So a ladder's maximum angle is 75 degrees for safety. How long of a ladder is needed to reach 90 feet up, or 90 feet high, all right? So I just want to make sure everyone understands the question. So let's go and take a look at the correct answer. The length of this ladder needs to be approximately 93.17 feet. All right, now if you got this right, you definitely get a happy face and an A plus. Congratulations, because you're definitely showing me that you know a thing or two about right triangles, and that's really the kind of the key to solving this problem. So let's go and get into it right now. And the first thing that we want to recognize is that we do have a math word problem. So you always want to use the rule of three, and this is my rule, but it's basically common sense, and that is read a problem at least 3 times. Really make sure you understand the problem and take in all the information. And then from there, you want to kind of model what's going on. So this first part of the problem, again, could be a bit confusing. So you may need to read it a few times. You're like, all right, a ladder's maximum angle is 75 degrees for safety. Now, for those of you that are math students, okay, one thing that you can do if you don't understand a question on an exam or test is to raise your hand, right? You could be like, hey, Mr. Teacher, I don't really know what's going on. Now, probably most teachers are not going to kind of clarify the question, right? But you just never know, okay? Maybe your teacher, maybe you'll catch them off guard and they'll kind of give you a hint. But nevertheless, don't be afraid to ask questions, even if you're not going to get an answer on an exam, right? But you can't solve a problem that you don't understand here. And again, we have this ladder, and it just makes sense that we can't have the ladder too steep, okay? We can't put the ladder like 89 degrees up against a building, because as you're going up this ladder, you're going to fall off backwards, right? So that's not a good idea. So again, the specifications here is 75 degrees is the maximum angle you can have on this ladder. So the question is, how long of a ladder is needed to reach 90 feet? Okay, so if you want to go up 90 feet, maybe you wanted to reach a side of a building that's 90 feet. Well, this ladder can only go, 75 degrees, okay? Let me kind of erase this here. So we want to max out this ladder's angle, okay? Because the higher the angle, obviously the higher the reach, because you don't want to put the angle too, low, maybe like 50 degrees, because we're not going to, get as high as we possibly can with this ladder. So all this, kind of discussion or thinking about this problem leads to the fact that you want to build a model of what's going on here, right? So anytime you have a math word problem, try to model it, try to visualize it, because if you can see the problem, oftentimes you can see the solution. All right, so let's go and do that right now, and here effectively is the problem. Okay, so here we want to go 90 feet, okay? Now the maximum angle, okay, of this ladder, this little yellow line right there, is my ladder is 75 degrees. So I'm going to go up 75 degrees because it's going to, give me the maximum reach on my ladder right here, okay? And I want to go 90 feet. Now here is the thing that we want to kind of understand is that the question is asking what, okay? The question is how long of a ladder, okay, is needed to reach 90 feet. So this is why it's really critical to draw a model of what's going on. So the question is how long is this right here? This is our ladder. That is what we're looking for in this problem. Okay, so again, how long of a ladder do we need? This is what we're looking for right there, this length to go up 90 feet. Now we do have to make some assumptions here, and that is the height of something. Now I'm kind of using a little building here or something like that. The height is going to be perpendicular to the ground. Okay, so you have to kind of make some simplifications here. You're like, well, what if we had a ladder and if it was kind of up against something that was kind of tilting this way? Well, the height is still going to be perpendicular to the ground. So we want to simplify the problem in a manner like this. Okay, so what we're talking about here is a right triangle. Okay, one that, this little notation right there, this little square, means 90 degrees. And you got to understand right triangles. This is critically important, not only in geometry, but in basic math and trigonometry. Okay, so really this comes down to how much do you know about right triangles? And let's go ahead and quickly review some things about right triangles. These are the things that we're going to need to understand in order to solve this problem. Okay, so I have two things here. So the first is a squared plus b squared is equal to c squared. And this thing I will explain in just 1 second. So let's go ahead and just focus in on a squared plus b squared is equal to c squared. All right, so this is a actual right triangle. It's actually called a Pythagorean triple. Now, this right triangle has the sides 3, 4, 5. Okay, so this is an actual right triangle. And again, what makes this a right triangle is that one of the angles is 90 degrees. And when you have this little square in one of the corners of a triangle, that indicates that this angle is 90 degrees, meaning that it is a right triangle. Now, anytime you do have a right triangle, this little theorem right here applies. Okay, now this is something you definitely want to put into your long-term memory if you've never seen it before. So a squared plus b squared is equal to c squared is called the Pythagorean theorem. All right, it is a critical property of right triangles, and it's something, again, you want to put into your long-term memory. But it only applies to right triangles. If you have a triangle like this that's not right, well, this doesn't apply. What does apply is something that's, this is a more advanced math, but it's what applies are things what we call the law of sines and cosines, which is actually kind of a variation or kind of an extension of this theorem. Okay, but that's not for this video. All right, so let's go ahead and talk about a squared plus b squared is equal to c squared because we're going to need to understand this in order to solve this problem. Now, the first thing that this a, b, and c stuff right here, these represent the lengths of or the sides of this right triangle. Now, c, okay, this longest side, the side opposite of our 90-degree angle, has a special name. Okay, and this is always our length c. This is called the hypotenuse, okay, the hypotenuse of a right triangle, and it's always RC. A and B are going to be the lengths of the other sides of the triangle. Okay, so what does this mean? Well, it means the following. Okay, this relationship holds true. A squared plus B squared is equal to C squared. This is always true in any right triangle, and basically what it states is that the sum of the squares of the shorter sides is equal to the square of the hypotenuse, right? So we can kind of see this mathematically. So if our hypotenuse, our longest side is 5, well, that's our C. Okay, so we're going to plug in 5 for C. And then our shorter sides can be A or B. Doesn't make a difference. This could be A, this could be B, or vice versa. Okay, so let's go ahead and plug in our information. So for A and B, we're going to have 3 and 4. So we're going to square those. 3 squared plus 4 squared. Is this equal to 5 squared? Well, 3 squared is 9, 4 squared is 16, and 5 squared is 25. 9 plus 16 is 25. 25 is equal to 25. Okay, so this is a relationship, this Pythagorean theorem, that you absolutely, again, must understand. And anytime you see a right triangle in mathematics, you need to be thinking about this theorem immediately. Okay, so let's go ahead and talk about this other thing. And this other thing is so cool because we're talking about basic right angle trigonometry. And what I have here is a sine. Now, I'm going to say this, and a lot of you are going to be like, hey, Mr. YouTube Math Man, I think you lost your mind. Well, not quite. Well, maybe a little bit, but let's just have fun with this. And this saying is the following. So, ka, toa. So, ka, toa. Yes, indeed, I said it. I want you to remember that. So, ka, toa. All right, now you're saying, okay, what are you talking about, Mr. YouTube Math Man? Well, I'm going to explain all this in just 1 second, but let's just make sure you get this phrase down. All right, so S-O-H, that's so. C-A-H, that's ka. And T-O-A, that's toa. Okay, so what we're talking about here is basic trigonometry, and really what we're talking about is something called trigonometric ratios. But if you look on your calculator, hopefully most of you have some sort of scientific calculator, and if you have your cell phone, you should be able to go to an option on your cell phone where you'll have a basic calculator. You could also put your calculator in some sort of scientific calculator mode, but you're looking for these buttons right here, sine, or SIN, COS, and TAN. So if you've ever seen these, you're like, yes, I've seen those, Mr. YouTube Math Man. What do those mean? Well, this has to do with basic trigonometry, and we're talking about something called trigonometric functions. All right, now this all pertains to a right triangle. Okay, so we're talking again about right triangles. So let's go ahead and take a look at this right triangle right here. Okay, so in this right triangle, we have an angle. Okay, let's say I have this angle right in this corner right here. We have three sides of this right triangle. Okay, now the first side, if you remember, our a squared plus b squared is equal to c squared. This longest side is the hypotenuse. So we're going to call this h. We're going to label this as h. Now the side that's opposite of this angle. So if my angle's in this corner, the side that's opposite is this side. Okay, this side is opposite of the angle. The side that is adjacent or next to that angle is right here. So that's going to be our A. Okay, so you got to make sure you understand this. So we're going to label the sides of this right triangle as H, A, and A. Okay, the hypotenuse, one is the adjacent and one is the opposite. And it all depends on where the angle is at in the triangle. So if our angle is in this corner, again, this will be the opposite. This side will be the adjacent. The longest side is always the hypotenuse. Okay, so that's going to help us understand the SOHCAHTOA business, which is going to make us understand the sine, cosine, and tangent of an angle. All right, so we're talking about basic trigonometry. So let's go ahead and see what this means right now. Okay, so the sine of an angle, okay, is equal to SO, right? So we're talking about this SO part, which means opposite over hypotenuse, the O and the H. So SO means the opposite over the hypotenuse. So the sine of an angle is the opposite over the hypotenuse. So in this particular triangle, or 3, 4, 5, the sine of this angle would be the opposite. In this case, that's 3 over the hypotenuse, 5, 3 over 5. Okay, so the cosine of an angle is the CAH, C-A-H. So the cosine is equal to the adjacent over the hypotenuse, and of course we can just plug in this respective information. That would be 4 over 5. And the tangent is of an angle, okay, or here in this particular triangle, is the opposite over the adjacent. That's our TOA, okay? And here that's 3 over 4. Now, if you take an angle, it doesn't make a difference if you have like cosine of 50 degrees and you want to make sure your calculator is in degree mode. If you plug that in, and you're going to see you're going to get some sort of number, some sort of value, right? So with our calculator and our knowledge of SOHCAHTOA, sine, cosine, and tangent, and a Pythagorean theorem, we can figure out the answer to this question. All right, so let's go and take the next step, which of course is having you quickly subscribe to my YouTube channel. Now, I definitely need your support. My channel is all about trying to make math clear and understandable and interesting, okay? Now, you know, I'm really, really grateful for all the people that have subscribed. And if you are a subscriber, I thank you so much. And really, I'm on a mission to try to produce, interesting, again, clear and understandable, helpful, exciting, math content, all right? And, for me, I have well over 3,000 plus math videos, and I try to mix it up from basic math to advanced math to word problems to everything else. And it's a lot of content, okay? And I really try to think about this. So my mind is really, kind of fully focused on building the content, but I do want to, have as many people, get some sort of benefit from my content, which means I need people to subscribe to my YouTube channel, as many people as I possibly can, because YouTube definitely considers that. And if I can help someone out there, with my math style or my instructional style, well, then I want to find that person, but I need your support. So hopefully you'll hit that subscribe button. And if you're going to do that, hit that bell notification as well so you can get my latest videos. One more thing, if you need full-on math instruction, check out my full main math courses. You'll find links to those in the description of this video. And what we're talking about here, I'm talking about basic geometry, or actually kind of high school level geometry. So you might want to check out my geometry course if you want to study more about right triangles, basic right triangle trigonometry. But if you really want to study trigonometry, then you may want to check out my pre-calculus course. And if you're like, hey, Mr. YouTube Math Man, I just kind of want to refresh my math skills, well, then check out my Math Skills Rebuilder course. Okay, so let's go ahead and apply all this knowledge that we know about right triangles to the problem. Okay, so what we want to do is simplify the situation and just focus in on this right triangle, okay? So this side of this right triangle is 90. We have this angle, and we're looking for the length of the ladder, so that's this length right there. So let's go ahead and just kind of focus in on the situation. So we have this as this one side is 90. Again, that's the height that we want to try to reach, 90 feet tall. We have this ladder, okay, its maximum angle is 75 degrees. We're looking for x, which is the length of this ladder. Okay, this is how long this ladder needs to be to reach 90 feet at a maximum angle of 75 degrees. So we're looking for x. But what we want to do here is think of this problem in terms of our SOHCAHTOA. So what information do we have? Well, we have this angle, okay? Now, what is the hypotenuse? What is the h? Well, again, the h is always going to be the longest side of a right triangle. And for the most part, it should be pretty easy to identify, but it's always opposite of your right angle. Okay, so it's going to be this one right here. There's the hypotenuse. So what is the adjacent side, or what side is next to this 75 degrees? Well, it's this side right here. So that's going to be our A. And the side that's opposite of this angle is O. All right, so we want to think of this triangle in terms of its adjacent, opposite, and hypotenuse, because we can use our trigonometric functions to solve for h, right? So that's what we're looking for right here. And we only have one length of this right triangle. If we had two lengths, right, if I knew this length and I had this length, well, then I can use the Pythagorean theorem to solve for x, this length here, but I only have an angle and one side. So I'm going to need some basic trigonometry to figure this out. Okay, so again, what we're trying to do here is to find the length of the hypotenuse, right? So that's this right here. So we're going to be focused in on our H and our O because we have the opposite side and we're looking for the hypotenuse. Okay, so which trigonometric function involves O and H, right? So kind of keep that in mind. And let's go ahead and show you which trigonometric function involves the O and the H. You got to go back to that same SOHCAHTOA, right? Just kind of go through your brain like, all right, SOHCAHTOA. Let me see here. O and H, well, it's sine. Okay, so sine involves the opposite and the hypotenuse, right? And that's the information that is involved in this problem. Okay, so we're going to use the sine to solve for this length of this ladder or the hypotenuse. Okay, so what do we have? Well, we have the angle, okay? We have the opposite, and we're looking for the hypotenuse. In this case, that is x. So the sine of 75 degrees is going to be equal to the opposite over the hypotenuse, okay? The opposite is what? Well, that's 90 feet over the hypotenuse, which is x, okay? So we don't know what that is. So all we have to do is solve this lovely equation right here, and we will answer the question, once we know what x is equal to. So we have sine 75 degrees is equal to 90 over x. So you can go into your calculator and get a decimal value right now for sine of 75 degrees. Make sure your calculator is in degree mode. But really what you want to do is just solve for x first and then do your calculations last. All right, so sine 75 degrees, I could put that over 1 and think of this as a lovely proportion. So I can use the cross product here to clear away the fractions. So x times sine 75 degrees, I can write that this way, is equal to 1 times 90 or 90. Okay, now remember sine of 75 degrees. Don't let this kind of be mysterious here. It looks kind of fancy, but this is just a decimal. All right, so if you want to go ahead and go into your calculator and take the sine of 75 degrees, you'll get that number, but there's no need to do that right now. So to solve for x, all we have to do, all right, let me go ahead and scroll down here, is divide both sides of the equation by sine of 75 degrees. And this is the way you want to do this, okay? So x is going to be equal to 90 divided by sine of 75 degrees. Now we can go into our calculator and you're going to come up with an answer. That's 93.17, all right? And of course, 90 is in feet, right? So our units of measure is in feet. And that makes sense, right? So 93.17 feet, that is an answer that seems to be reasonable in terms of the length of a ladder that we need, okay, at 75 degrees to reach 90 feet. Okay, so hopefully a lot of you out there that didn't know much about right triangle trigonometry or right triangles actually learned something. Okay, this stuff is not that difficult. And I know at first glance it seems like, oh, this is extremely advanced. It's not that bad. Okay, math is just a total. Well, for the most part, learning mathematics is a total amount of skills that you have, right? I don't know if maybe that's a poor way to kind of explain what I'm trying to say. And what I'm really trying to say is this, okay? There is a lot to learn in math, and you can't be like, hey, Mr. YouTube Math Man, teach me calculus or teach me trigonometry. Well, I would love to, okay? We'd love to kind of get into these more advanced topics, but this stuff has to kind of be learned in order, right? You got to know these other skills before you get into this stuff. And that's why, it's really important to realize that when you are practicing mathematics, if you get something wrong, that's an opportunity to strengthen a skill that, needs to be reviewed or strengthened. All right, so with all that being said, I definitely wish you all the best in your math adventures. Thank you for your time and have a great day.